Alright, let's look at section 8.4. Topic is visualizing equivalence classes. Alright, so let's look at this example. Alright, so we have this equivalence relation given, right, on a set containing 1, 2, 3, 4, 5, 6, and 7. Alright, so let's try to make a table for this equivalence relation. Right, so I'm gonna put the the cross x when number is related to that number. So you have 1 is related to 1, so I'm gonna put a x here, right? And 1 is related to 3, so x here. 1 is related to 4, I put x here. And 2 is related to 2, so x here. And 2 is related to 7, so I put x here. And 3 is related to 1, so x here. And 3 is related to 3, so x here. And 3 is related to 4, so x here. And 4 is related to 1, so you have x here. 4 is related to 3, x here. And 4 is related to 4, x here. Right, 5 is related to 5, so x here. And 5 is related to 6, x here. 6 is related to 5, x here. And 6 is related to 6, x here. And 7 is related to 2, so x here. 7 is related to 7. Alright. Alright, so you can see that since equivalence relation is reflexive, you can see that all the diagonal is filled with x's. Right? And also, if you look at the upper triangle, you can see that there's a symmetry, right? You have a symmetry here. Here you have 1 is related to 3, then 3 is related to 1. For example, 2 is related to 7, and a 7 is related to, and so on. So you have a symmetry between upper triangle and the lower triangle. All right. What if we rearrange it so that I group things together. So since y is related to 1, 3, 4, I'm going to put 1, 3, 4 together. And 2 is related to 2 and 7, so I put 2 and 7 together. And 5 is related to 5 and 6, so I put 5 and 6 together. Right? Let's fill the x's again and see what it looks like. All right? So you can see that the 1 is related to 1, 1 is related to 3, 1 is related to 4, right? Then 2 is related to 2, so 2 is related to here, 2 is here, 2 is related to 2, and 2 is related to 7, right? 3 is related to 1, and 3 is related to 4, or actually 3 is related to 3 too, and 4 is related to 1, 4 is related to 3, 4 is related to 4, right? 5 is related to 5 here, and 5 is related to 6, 6 is related to 5, and a 6 is related to 6, and a 7 is related to 2, 7 is related to 7, right? So this way you can definitely see some grouping. You can see that there's a grouping over here. So you can see that here, this is a grouping. And since all the boxes are filled with x, so that means that there should be all possible relations are going to be connected. So you have 1 is related to 1. So everyone is related to everybody else in that subgroup. And the same thing with 2 and 7. And they have all possible relations filled in, and the same with 5 and 6, right? Right, so the equivalence class is basically these represents equivalence classes. So for example, equivalence class represented by 1 or 3 or 4, doesn't matter, is going to contain 1, 3, and 4. And the equivalence class represented by 2 would be the set with 2 and 7, right? The equivalence class represented by, say, 5 would be a set with 5 and 6, right? Right, so you can see that there's a connection between equivalence class and the partition. You can see that this is going to be a partition. If you put P partition as, so first set subgroup has 1, 3, 4, and the second subgroup is 2 and 7, and the third subgroup is 5 and 6. All right. So equivalence class can be visualized kind of this way. So if you have a bunch of things, you have equivalence class 1, 3, 4, and you have 2 and 7, and 5 and 6, right? So among these three guys, we have all relationships. 1 is related to 3, 3 is related back to 1, and 1 is related to 4, 4 is related back to 1, and 4 is related to 3, and 3 is related back to 4, and the same thing, 2 is related to 7, and 7 is related to 2. Oh, actually I forgot, the 1 is related to itself, and the 3 is related to itself, and the 4 is related to itself, and so you can see that 2 is related to itself, and 7 is related to itself, so that forms another equivalence class. And 5 is related to 6, 6 is related back to 5, 5 is related to itself, and 6 is related to itself, right? So you have those. So those are the equivalence classes, and this is the set A, right? So you can see that there is a close relationship between equivalent classes, and partition of the set. All right, so you can kind of visualize that from these tables and the diagrams. All right, that's it. I hope that this was clear.